Hello, AP Chemistry students. It's me, Dr. V, and it's a good day to do some AP Chemistry exam review. It's always a good day to study chemistry, folks. In this webcast, we're going through free response question number 7 from the 2023 exam. This is one of the short free response questions. It's scored out of 4 points. And the short free response questions, as you may know, have 2, 3, or 4 parts. Grab your calculator, your periodic table, and your formula sheet so you can follow along with me. I really encourage you to be an active participant in this. Let me introduce each part of the problem, and then pause the webcast, try to answer it on your own, and then listen to my explanation of how I arrived at my answer. And keep track of your score as you go. Did you earn the point? Did you not earn the point? Did you have a really thorough, great answer? Did you need a little enhancement? Was there something that confused you or something you forgot? Knowing that will help you write better responses in the future, right? And that's kind of why we're here. Let's jump right into the problem. Strontium hydroxide dissolves in water according to the following equation. The KSP expression for strontium hydroxide is provided. So we've got strontium hydroxide as a solid. The products are strontium ion and 2 hydroxide ions, and we have the equilibrium constant expression, the KSP. Student draws the particulate diagram shown to represent the ions present in an aqueous solution of strontium hydroxide. The water molecules have been omitted just for clarity. Identify the error in the student's drawing. What's wrong with this picture? One piece of advice I have for you is when you see these particle level diagrams, count the particles. How many strontium ions are there? How many hydroxide ions are there? Quantify that. And when we look at the diagram, I see 4 strontium ions, those are the dark gray circles, and the other ones are the hydroxide ions, and I see 4 hydroxide ions. But if we look at the formula, if we look at the balanced equation and the formula very clearly show us that for every strontium ion, there are 2 hydroxides. The diagram has 1 hydroxide ion for each strontium ion. Now, that's not going to cut it. That's really the mistake here. If there are 4 strontium ions, there should be 8 hydroxide ions, but there's only 4. The other thing I wanted to mention is that the diagram isn't neutral. This solution should be charge neutral overall, right? For every strontium ion, there are 2 hydroxides. So if I've got 4 2+ ions and only 4 -1 ions, that's not a neutral solution. It doesn't show conservation of charge, so that's also a problem, but it really comes from the fact that there aren't enough hydroxide ions shown. That's what you needed to state to earn 1 point here for Part A. Part B goes on. The student prepares a saturated solution by adding excess strontium hydroxide solid to distilled water and stirring until no more solid dissolves. I'm dissolving as much strontium hydroxide as I can at these conditions. That's what a saturated solution means. The student then determines that the strontium ion concentration is 0.043 molar in this solution. And the question is, what's the concentration of the hydroxide ion in this solution? Now, Part A was all about that 2-to-1 ratio, 2 hydroxides for each strontium. And that's really the key here as well. So if the strontium ion concentration is 0.043 molar, the hydroxide ion concentration is twice that. I need to show the work and show that calculation, and I get a concentration of 0.086 molar hydroxide. And that's what I needed to state to earn the point for B Part 1. There's a second part to Part B. Calculate the value of KSP for strontium hydroxide. Now, considering we were given a KSP expression right at the beginning of the problem, it's really not a surprise that we have to calculate a KSP value here. So we've got that KSP expression. From Part B, we were given a strontium ion concentration, so we're going to use that. And of course, in our previous part, we had just calculated the concentration of hydroxide ion, so we're going to use that answer too. And that means we're now ready to substitute and evaluate. We know the strontium ion concentration. We know the hydroxide ion concentration. We have to square the hydroxide ion concentration and make sure we actually do that in our calculator. That's a common student mistake. And we get a value of 3.2 times 10 to the minus 4 for the KSP. It's a small number, which is what we expect for a slightly soluble salt. And we needed to do that for 1 point. It needs to be consistent with our work from B Part 1 and show with the complete setup, and that's what we need to do. The student prepares a second saturated solution of strontium hydroxide, but now it's an aqueous 0.1 molar strontium nitrate and not water. Will the value of the hydroxide ion concentration in this new solution be greater than, less than, or equal to the hydroxide ion concentration in the first solution? Justify your answer. And it says to assume constant temperature. We're making a note of that because when the temperature is constant, the value of KSP won't change. We do need to justify our answer, and that means we need to use math-based reasoning in order to back up our answer. So let's think this through. We know the KSP expression, and the whole idea here is that the product of the strontium ion concentration times the square of the hydroxide ion concentration is a constant value. That KSP is a fixed value. So if we're making the solution now in 0.1 molar strontium nitrate, we've got a common ion effect. We've got an outside source of strontium ion besides what we can get from the strontium hydroxide. So essentially what we're saying is the strontium ion concentration is about 0.1 molar. If the concentration of strontium ion goes up, the concentration of hydroxide ion would have to go down in order to keep the KSP value constant. There's another way that we can think through this. Sometimes students are really mathy and they like to do calculations. And we spent a lot of time in my classes doing ICE tables, and I think that's a good approach here as well. If we think about our ICE table in this common ion effect problem, the strontium ion concentration is starting at 0.1 because of the 0.1 molar strontium nitrate, and the hydroxide ion concentration would initially be at 0 because there's no significant source of hydroxide ion in the strontium nitrate solution. In order to establish equilibrium, the strontium ion concentration has to go up by x. And the hydroxide ion concentration has to go up by 2x because of that 1:2 ratio from the balanced equation. So at equilibrium, the strontium ion concentration would be 0.1 plus x, and the hydroxide ion concentration would be 2x. But you'll notice I'm going to make an approximation here, which is similar to what we did earlier when we were talking about part C. Because KSP is much less than 1, I can assume that 0.1 plus x is approximately 0.1, which really is the same approximation we made earlier without writing it all out. But what we could do now is actually solve for the hydroxide ion concentration. We can substitute the 0.1 in for the strontium. We can substitute 2x in for the hydroxide. We still have to square it. And when we solve for x, we get 0.028 molar. That's definitely smaller than what we had in part B. The hydroxide ion concentration in this second solution, in the common ion effect situation, will be less than the hydroxide ion concentration in the original solution. And that's 1 point. So how did you do? This was a very reasonable KSP problem. Explaining what an equilibrium constant is, thinking about the relative concentrations of ions in solution, thinking about the common ion effect. So a really nice little KSP problem. AP chemistry students really need to be able to work with KSP problems. They show up a lot. The average score on this question in 2023 was 2.23 points out of 4. So a lot of students scored 2 points. A smaller number of students scored 3 points on this problem. So if you scored 2 points, you're in good shape. If you earned 3 or 4 points, you're doing pretty well with KSPs. If you found this webcast to be helpful, like the video and leave a comment, and remember to subscribe to my channel. I'll be recording more review videos. I have a whole bunch of review videos on my channel, and use them. And keep studying chemistry every day. Take care, folks.